Hey guys, so I'm going to take you through how to do the target A notes where on page 5 where you do not have a graph, and it's actually more fun when I give you the equation instead of the graph because you get to go put the graph or the equation in Desmos, and Desmos does a lot for you. Before we start though, you're going to want to be on the graphing calculator for Desmos, and so if you're not sure how to get there, if you've been using our regular calculator, you will want to go to Math Tools right here and then go to Graphing Calculator, and it'll take you to where you want to be. Another thing I want to show you is that if you go to our Teams page and you go to KC2 on the left-hand side right here, you're going to find the Target A resource sheet that we're going to use for these notes. You shouldn't be doing anything for this target without the resource sheet. This will help you, I promise. And so we're going to go through the notes and we're going to find the key features of this graph, but we don't have the graph. So the first thing we need to do is go find this graph. So we need to go graph it. And we're going to go put this entire formula into our graphing calculator. So I'm going to minimize this screen so I can see both of them at the same time. And I'm going to minimize this screen. And I'm going to go put this in. I don't have to put the f of x. You can type f of x in there. And you can either use this keyboard right here or the one on your computer. And I'm going to do, I'm not going to put f of x, so I'm going to go x squared. You can type it like I said, or you can put it here, x squared plus 5x, again, x is over here, plus 4. I'm putting exactly what I see in the notes. I'm putting this exact thing right here. This. And then I should see something that looks like a parabola. This is what we've been doing. So it looks nice. And you're going to want to use this graph because this graph will give you a lot of pieces of information without even asking. So we will use it when we get there. So let me minimize this a little bit more. Oops, that did not do what I wanted it to. There we go. Alrighty, so we're going to look at this graph. Do I have a maximum or a minimum? And remember, a maximum or a minimum is where my graph is either has a minimum point. That means I can see the lowest point on my graph. It has a divot. It's got a deep point, kind of like the bottom of a valley. Or if my graph has a maximum, I can see with my own eyes, I can see the top of my graph, like the top of a mountain. So I hope you agree with me that my graph has a minimum. I can see the very bottom part of my graph. So my graph has a minimum. And then your vertex is where your minimum or your maximum happens. And I already did it on Desmos without realizing, but if you click on some points on your graph, Desmos will tell you where it is. So what I mean is your vertex is a point, x comma y. And if I click on where I think the bottom of my graph is, my minimum, it'll tell me where that point is. So my vertex is negative 2.5 comma negative 2.25. So my vertex is negative 2.5, comma, negative 2.25. Okay. And so again, that came right from Desmos. My vertex is where my maximum or my minimum happens. Then your sign of your leading coefficient. That means, did my graph open up or did it open down? Did my graph open up or open down? In order to answer that question, you need to be like, my graph is the ends of your graph. The ends, are they pointing to the sky? So these over here, are they pointing to the sky or are they pointing towards the ground? These are pointing towards the sky. So my graph opens up. So that is a positive sign. A, which we're not using, is a positive number. Sometimes the question will say, does it open up or down? Sometimes it will say signs of the leading coefficient. Please watch the next video where I'm going to do increasing, decreasing, x-intercept, y-intercept, domain, and range. It'll be one more video.